We have here quite a densely worded question, so make sure you read it through a few times so you can pick up on all the little details, all the little hints they're trying to give you here. And then pause the video and have a go at writing down some potential risks or harms. With this, because some of the reasons you'll write down, some of the harms you'll write down are going to be more convincing than others, try to write down a few and then pick the best ones. And what we'll do in a moment is decide which are the good ones. So here are some things. Have a quick read through. Some of these might get you the mark. Some definitely will. Some almost certainly won't. Now, I think one of the big important things here in this last sentence, AI will automatically estimate clothing sizes, blah, 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 based on the purchase history of the user and other similar users. Now, that to me, how do we decide what counts as a similar user? Is that to do with what you've purchased before? Or so if you've purchased the same things as three other people who have purchased all the same things, does that mean the next thing you purchase is going to be the same? Or are they using demographic indicators? Okay? Either of those could introduce, and this is probably the strongest answer here, would be bias here. So there could be bias which recommends things for you based on unfair, either prejudice based on some kind of demographic trait or an inadequately trained neural network. Let's go through the rest of these. It could harm your self-esteem if you're a different size than you thought. I really think that's a little bit weak. You know, put a little wavy sign there. It's a bit vague, and it's not really to do with the AI. This one certainly is. We have security of personal data. That one I think probably would get you the mark, although it's the same as just using the internet in general. But we would probably get away with that. This next one here, putting your credit card details online, that really is nothing to do with the AI. That's to do with online shopping. So I think that would be a cross. I think that would be a cross as well, that top one. AI could make incorrect recommendations. Well, yeah, things don't work the way they're supposed to. That's not really saying what the harm is. And anyway, things go wrong, and we try and train them so that they're not. But yeah. Lack of transparency about how recommendations are made. I mean, this one seems a little bit less weak, a little bit weaker than bias to me. So it would need, because it is a neural network, it can't tell you why it's. Well, is it a neural network? No, it doesn't actually say, does it? At this point, we're not told if it's a neural network or machine learning. So we may not know how it's making the recommendations. It won't say people like you bought these before, or people who bought the things you bought before also bought this. So this one's okay. Now I've just mentioned at the bottom here some keywords. These are from the study design: bias, transparency, and accountability. Accountability doesn't really seem too relevant here. Accountability is like if self-driving car crashes, who's to blame? Privacy has been added, like in just a lot of people seem to add this as well. It seems to come up a lot with any sort of personal data. And human dignity, I think a good example of this, if anyone's seen the Black Mirror episode, where they have a dating algorithm which tells you with 99.9% certainty who your best partner is going to be. That one could argue that takes away the agency of being a human. So I don't know if either of these next two are relevant for this one. So overall, I would certainly go for this one here with the arrow, and probably the other thing, the second best one is the security of personal data, like things being stolen, something like that. But the key thing here, I would say, when you're doing these questions, write down a few answers and then pick the best ones, or at least think of a few answers and pick the best ones. Don't just go with the first thing you think of and go, oh yeah, it's kind of all right, because it might not be. Okay, next one. Now they've given us some fairly specific information here. Hundreds of millions of parameters and 5,000 users. Well, clearly that's not enough training data. So the problem we have as a result of that is overfitting. So we'll have very accurate predictions for the training data, but not reliable for unseen data. there's a tendency sometimes to talk about processing power. You just say, "Wow, it's so big. How will that possibly work?" But that's not really. We're not given any information about that. Now let's just discuss the difference between underfitting and overfitting, and we can think of this as analogous to modeling things with polynomials. So here we have a set of training data, and we're going to try to model. I'm just going to demonstrate the difference between underfitting and overfitting. So underfitting is when the model we have is just not complex enough. So we might just go doof like that and say everything above the line is red, everything below the line is blue. Well, that's awful. Like there's just the model is not capturing anything to do with the data. And we can also see, let's just put that back, the accuracy for this, if we're saying we've got blue here and red here, we can see that that is going to be bad for both the training data and for unseen data. Now let's consider overfitting. And overfitting, it's analogous to the situation we've got here. The millions of parameters, we could think of that as a polynomial with millions of degrees. And so we could have a model which does something like this, which goes, well, so it's going to try and be like a function. So it would perfectly separate the red and the blue. Yeah, obviously that's not exactly a function. It doesn't have to be a function. So that would be, I mean, it's obviously not a polynomial, but let's just ignore maths for a little bit. So you see, it captures every little nuance of the data. Like one outlier will change the nature of the model. Okay, so it captures all the noise of the training data. And as we can see, it would be very accurate for the training data. But it would be not accurate for unseen data. Because, for example, the way this kink goes down here, that's not really, that's quite arbitrary. That's just because of one or two funny points. So the chances of the unseen data fitting all that same noise is rather low. So what we'd be aiming for really for this is going to be a model that's doing something like that. I mean, let's just do that by eye. We can roughly see where the data is being separated. And if we have it like this, we can see that not every piece of data is going to be correct, but it will have a better overall error or accuracy rate for unseen data. So make sure that we're clear between the differences between underfitting and overfitting. Overfitting is not enough data for a very, very complicated model, and underfitting is I don't know if we say there's too much data, but we'd say the model is not complex enough to capture the patterns within the data.